In this video, we're going to look at how to sketch square root graphs. To begin with, we're going to look at where the square root graph came from so that we can better understand its shape. Then, we'll look at how to sketch the square root graph by hand. And then at the very end, we're going to look at one of the strange results that sometimes comes up when solving for x-intercepts. For those who don't know me, my name is Chris Iannazoni. I used to work as an engineer for a defense company, and I've since left that to start a career in tutoring. I make these videos so that VC students can do the best they can in math methods. With that out of the way, let's get into it. The origin of the square root graph came from the relation y squared equals x. You can think of this as the inverse of the quadratic, where for each x value there are two y values. We don't really look at this graph in methods, but I think it's important to understand where the square root graph comes from because it will explain an odd result later down the line. To turn this into the square root graph, we just square root both sides. And when we do that, you'll notice that we only take the positive half of the relation y squared equals x. The reason why is because, well, we want the graph of root x to just be a function, not a relation. A function requires us to have only one given y value per x value. The general form of the square root is written above. Let's see how each term impacts the graph. The a term is a dilation factor from the x. It's responsible for stretching the graph vertically. If a is larger, then it's going to get further away from the x-axis. If a gets closer to 0, it's going to get closer to the x-axis. The b term is very similar to a. It actually works in the opposite way. So if b gets larger, we get closer to the x-axis, and if b gets smaller, we get further from the axes. Reflections are identified by negative signs. A reflection about the x-axis is given by a negative sign at the front of the function, and a reflection about the y-axis is given by a negative sign on the x variable itself. Just a quick note about having a negative sign inside the square root. You might think, correctly, that you can't take the square root of a negative number, and that is true, for numbers, not for variables. Consider the case where x equals -1. If we were to substitute x equals -1 into the equation, the double negatives will cancel out to become a positive again. This is why the graph of square root of -x is only defined for negative x values. The last thing we'll consider are the translation terms. These are responsible for shifting the graph horizontally or vertically. Horizontal translations are determined by the h term. If you have x minus h, then you're shifting to the right by h. In this example here, we have x minus 2, hence we're shifting the entire graph to the right by 2. If you instead had x plus h, then you would be shifting left by h. In this example, we have x plus 1, hence we're shifting the graph left by 1. Vertical translations are determined by the c term. If you have plus c, then you're shifting up by c. In this example here, we have the graph of square root x plus 1, hence we're shifting up by 1. If you have minus c, then you're shifting down by c. In this example, we have square root of x minus 2, hence we're shifting down by 2. So, when it comes to sketching the square root, you need to know three things: the starting point, axes intercepts, and endpoints. We'll use the following framework to help us with this. Let's have a look at an example. To begin, we just want to make sure that we're starting with the general form of the square root. This will allow us to figure out what each of the terms do. In this case, all we need to do is take the coefficient off of the x as a common factor. From here, we can easily identify the starting point of our square root graph. The x-coordinate is given by the horizontal translation, and the y-coordinate is given by the vertical translation. Altogether, this is going to give us a starting point of 1, 1. Next, we move on to axes intercepts. To solve for the x-intercept, you're just going to set y equals 0 and then rearrange to solve for x. This is going to require us to square both sides of the equation. For y-intercepts, you're going to sub in x equals 0. And after you simplify this, you're going to have a negative number inside of your square root. That's your indicator to say that there is no y-axis intercept for this function. The next step would normally be to find the endpoints of your graph. In this case, there is no restriction on our domain, so we're not going to do this step. Now that we have all of our key features, we're just going to sketch the graph with all those key features. If there is a restriction on the domain, then you do need to find the endpoints. We've actually already found one of these endpoints earlier. We already know the coordinate 1, 1 is the lower bound. To find the upper bound, we just got to sub in the upper bound into our function. Get a corresponding y value, and then that becomes the final coordinate. Once we have those two coordinates, we just cut the graph off early. Just be mindful of the brackets. Square brackets mean that you have a full circle, and round brackets mean that you have an open circle. Okay, so here's the weird thing. Sometimes, when you're solving for x-intercepts, the math will find one even though there isn't one on the graph. Let's have a look at an example that explores this. This one is a pretty standard square root graph. It's just root x plus 1. We have a vertical translation of 1, hence our starting point is going to be 0, 1. Now here's the weird bit. When we go to find our x-intercept, we're going to sub in y equals 0 and then rearrange, and that's going to give us x equals 1. What's the issue? Well, here's what the graph's supposed to look like. As you can see, there's no x-intercept on that graph. So what happened? Well, here's what we actually found. When we did our math, we didn't account for the fact that we only want the positive half of the square root. The x-intercept that we found belongs to the negative half of the root. There isn't really an elegant way to avoid this. You pretty much just have to be familiar with the shape of the square root and then know in advance whether or not you're going to have x or y intercepts. The main thing I'd be looking for here are the reflection terms. So if you really want to hone in on this, go back to the section where I was talking about reflections and study those graphs. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool, you should check it out. I'll see you there.